Ravi is a data scientist at the SuperGrow Financial Advisors. Ravi reaches his office at 8 a.m. sharp every morning and starts his day with a fuming hot cup of coffee. Ravi loves his job. Being a data scientist is cool. It lets him use a variety of cool technologies and skills and is very creative too. The part Ravi loves most is that his job is very critical to his company. Being a financial advice and investment company, they need to understand the market trends and future prospects very well to make solid decisions for their clients, and Ravi's job is in the center of all that. Every day, Ravi receives tons of data or feeds on financial transactions and reports on various investments, and return information from the advisors in his company and various other sources. His job is to collate all of them and creating insights, trends and prediction models so that SuperGrow advisors can use them to make better investment decisions for their clients. Cool, isn't it? Let's look at how Ravi achieves all that. Ravi has just received a mail that this morning's Bloomberg feed has been uploaded into the database. He has also received a bunch of weekly data sheets from the High Net Worth Division's chief advisor. Ravi needs to upload them into the DB using an app she has access to on his system. But hey, hang on, before Ravi starts the uploads, let's take a step back and understand the business goals he is serving. That exactly is the first step for any data science, predictive modeling endeavor. Ravi needs to understand the business goals well. The business goals should be well formed and have specific targets. Smart, that is specific, measurable, achievable, realistic, timely. One such business goal that Ravi serves through his job is generating global trends of Forex and trend prediction for next month based on various parameters. That sounds really cool. And needs Ravi to use his data analytics and predictive modeling skills. The next step in data science is collating data. Data may come from a variety of sources. Data sources can be various divisions, like in case of Ravi's company, SuperGrow, all the advisory divisions such as High Net Worth Division, Real Estate Division, Commodities, Metals, focused on various segments of assets, and customers generate their own data and are sources for all the data Ravi processes. Variety of data also mean that Ravi receives these data in various shapes and forms. Data could come to him in the form of database tables, Excel sheet, data warehouse, flat files in structured as well as unstructured, etc. You must be realizing now that Ravi's task is seeming more daunting and specialized. But worry not. Ravi has his magic spelled on all these variety of sources and forms of data that come as input for his data science work. Ravi has created transformation pipelines for each source of data. These transformation pipelines ingest the data, and as they arrive, the steps built within the transformation pipelines convert the data into meaningful and uniform patterns that can be processed together. Data transformations can be of the following types, and they are applied as the need of the specific scenario is: merging of data from various sources, aggregation of data as summary, generating additional derived attributes when existing attributes are not good enough for insights, analytics, or predictive modeling, scaling of data to bring numeric data into the same scale without losing their values. Scaling is required for most machine learning or predictive modeling tasks. Transforming existing features to make them meaningful for the analytics task in hand. And so on. Now that Ravi has set up his data in order, it's time to move on to the next and very important process step in data science, that is exploratory data analysis. Remember that data transformation and data analysis can have a few back and forth. As part of data analysis, Ravi may figure out a few more transformation needs, and he will go back and perform them and come back to analysis. Exploratory data analysis, or EDA, uses a variety of skills including statistical techniques, analytical skills, visualization techniques, and so on. Some of the technologies that help in performing data analytics tasks are programming with Python, alternately R language, SQL, and NoSQL skills for analysis of data in RDBMS tables or NoSQL databases. Microsoft Excel is always a very handy tool for data analysts for small volume of data, etc. Apart from these, data scientists are also expected to possess good understanding of statistical methods, linear algebra, and critical thinking skills. Visualization is a very specialized area of data analytics. Python offers a number of very powerful libraries such as Matplotlib, Seaborn, Bokeh, and so on, using which you can bring out some very crafty charts and graphs that are outputs from your data analytics. Additional tools such as MATLAB or Tableau are also very popular for analytics. Ravi uses Python and its visualization libraries to create power visual analysis of his data for his management. Nifty, and he sends them away to them. But he still needs to perform the predictive modeling for projecting future trends. As part of data analysis, Ravi will surely find a number of additional transformation needs. Data almost always will come with errors, anomalies, and missing values. Further transformation will be required to take care of these issues before data can be fed to predictive modeling or visualizations. There are various techniques to deal with each of them. Python by far comes in the strongest in such manipulation and correction of data as part of your EDA and transformations. Once Ravi is done with EDA steps and transformation, he is now happy that his data is in order. He now focuses on setting up the predictive modeling. Predictive modeling uses various machine learning algorithms. There are two main types of learning algorithms that are used for predictions: regression methods that predict continuous numeric values from model they create from labeled data comprising multiple attributes. For example, given stock trends, Ravi can use a regression model to predict future trends. Regression models can be linear models or nonlinear, polynomial models as well. On the other hand, classification techniques learn to predict discrete values, which are also known as labels or classes, from historical transactions. For example, given historical transactions and results, Ravi generates advisory reports on various stocks, predicting whether they are buy or sell based on current values. The last part of Ravi's job is to deploy the models that he has developed into live or production systems. His systems team helps in doing that using DevOps, or more specifically various MLOps processes using data pipelines, modeling pipelines, and continuous delivery pipelines. Monitoring of the results and the health and performance of the models in the live systems is another important aspect that Ravi and the systems team have to keep an eye on. Ravi also has to deploy his models iteratively in live, as he rebuilds the models periodically with new data that he receives. This ensures that the predictive models are kept up to date with current market data. This summarizes what Ravi, our data scientist, is up to. He is super happy at the end of the day. His company drives superb results for their clients because of the analytics and models that he develops, leading to better investment decisions by super grow financials, increasing customer asset value, and resulting happy customers for them. In summary, the data science process steps are as follows. You start with data collection. Input data needs to be cleaned and transformed. The exploratory data analysis, or EDA process, will follow to discover insights and patterns. Such insights and trends will be presented through visualization methods. For further trends and decision support, predictive modeling will be performed using various machine learning or predictive modeling algorithms. Models developed will be deployed in production using MLOps processes. Productionized models will need monitoring, and finally, models are rebuilt with new data periodically to keep them up to date. This doodle is brought to you by Texans, a leader in deep tech learning. Please subscribe, like and share if you liked this video. Visit us at texans.ai.